2013 Nissan Murano 3.5 liter V6. This vehicle has about 200,000 miles on it. Quick rundown of the engine. It has 3 timing chains in it, a primary and then 2 secondaries. Basically the exhaust cams run off of the intake cams, and then the primary goes around the intake cams and down around the crankshaft. You'll see why I'm explaining that. Me and another coworker were kind of attacking this thing. You can see my trouble code list right there. I basically had 2 intake timing control solenoid or timing control codes, a lean code, and a multi-cylinder misfire. First off, just scanning this vehicle, it's running a bit rough in the bay. Jason had already taken a cam and crank correlation and had, I think at this point he had used his pressure transducer, which I'm going to go over that capture. He uses a PV350. He has all the custom probes from Auto Nerds because he is an Auto Nerd member. I would tell anyone to go over there and get yourself involved with the Picogroup. There is so much more than just buying the scope there. Lots of forum stuff, lots of stuff on our cloud or drop site, lots of custom probes for PV350, that little amp clamp that you may have seen my last video or 2 videos back. These things are already made and there for you. Any overlays that I use, it all comes from Auto Nerds. It's all part of the package deal. When you buy from them, you get all this extra stuff, and as usual there'll be a link in the description box. So we decided to go after the timing chain or alleged timing chain issue. Basically I have a couple of codes there, and throughout this video you're going to see scan data and you're going to see cam and crank correlations. You will not see wiring diagrams this time. This is purely mechanical. Video may be getting a little long because I want to go over the pressure stuff. Had to shift directions a couple of times in the diagnosis. This thing was fun, man. It was kind of a head scratcher. Unfortunately, the customer took the vehicle. I have documented the problem, and we even have some known good, but the customer took the vehicle. I'm thinking he's going to try to go back to a shop that may or may not have created this problem. Don't know, don't want to be in the middle of that. We offered the repair, obviously, and he elected to take it on. Just a quick glance under the hood, you could see where the intake boot had been replaced. You could kind of see where the engine had been taken apart. Maybe the intake had been off of it. The transmission had been replaced, or at least in and out. The transmission case is a whole lot newer than the engine block, which you'll see in a video, so I'm thinking it has CVT trans put in it. And then of course we're going to show you the problem. There again, this thing was kind of neat. It was a head scratcher. I want to thank Jason for getting some of the captures. This was actually in his bay, but him and I kind of put our heads together and came up with the fix. It took us about 4 o'clock one evening, a couple of text messages riding home of things he found, and then the next morning some more WPS captures, and I think you'll find that stuff kind of interesting. So let me get off here, quit yapping. Thank you guys for watching and liking and subscribing and all that good stuff that YouTube people are supposed to say. And see you on the first capture.
Excuse me, these are the codes we're chasing. 2 intake codes, fuel lean, and multi-cylinder.
So it's getting kind of late in the evening. Jay is messing with this thing, and I'll go over there, and you could rev the engine and it revs kind of sluggish. It's running a little rough. It's got the codes in it that I showed you on the little video, and so he's kind of going after the timing codes. Just, you know, why not? Let's go ahead and if this car has major mechanical problems, let's go ahead and disclose that to our customer first before we start chasing other things. That was kind of our strategy going into this, and of course any sort of strategy like this is always fluid. A lot of forks in the road. You just go until some data tells you to take a different turn, and then that data may take you to a different turn. That's kind of the way this diagnosis went. So this is his scope. He has a 4425, which is obviously a great scope. He did buy it from Auto Nerds. Let me make sure I'm not telling you a fib here. Make sure this is his capture. Yes, 4425. He's got a good sample rate. He gets to work with me every day. I don't know if that's good or bad, but I'm very strict on my sample rate, and he has done a great job making sure he does that. So cam and crank, here we go. Neither one of us have a known good, but there's still information that can be gotten. First thing I noticed is, now this is intake only, we do not have a monitor on the exhaust, is both of our cams are in line. They are not out of time from each other. Our scan tool, which you're going to see, is showing me a 20-degree advance with no command. I probably should show that video first, but you'll see that. Now where these two cams, I'm looking at the falling edge right here, where these two cams should line up on the crank, just because I've looked at so many Nissan cam and cranks, to me it looks a little early. It's lining up, and what I'm talking about is right here. Usually I see them over here. I don't like to see them over here, but there are some newer engines that are. I kind of compared this to a 3.5 that I have in my library, but it was an older engine. It was a 2004. I'm not going to make a decision on that based on an 04. I had an 06 Maxima, which is a 3.5, and it's over here where I would expect. Grab too much there. So we're not going to make a call on this information right here. This is just kind of a clue. I'm saying this: if this chain has jumped or moved, it has to have moved off the crankshaft, because one thing that both cams have in common is the crank. So we learned that if it's jumped off the crank. We know a CVT's been put in this thing, and we know you have to rotate the engine around to take torque converter bolts out. So is there a possibility somebody rotated the engine backwards and maybe jumped a tooth off the crank? I don't know. These are all things I'm thinking about while we're trying to figure this car out. So we decided to go in cylinder. Jason has a Fluke PV350, and he, like I said in the opening, he has all the probes from Auto Nerds. So we set this thing on a -20 to 200 psi. We stuck it in cylinder 2, and this is what we got. So what I'm going to do is I'm going to turn off these channels just to keep down on clutter, and we're going to focus on the WPS. So this is going to tell me if my cam timing is on or off. The engine's running a bit rough, and now we've taken away one of the spark plugs. So we have really created more of a rough running engine. So I'm going to kind of, you can see it's got some lows and highs in here. So I kind of like this area right in here. But first off, I want to notice right off the bat, this thing has 102 psi at idle. That is, to me, too high for this engine. I usually expect to see them no more than 90, 75-ish is where I generally see these. So I'm already seeing an issue, because in order to have high compression, you've got to have more volume to compress. So let's zoom in and just start poking around at this thing. Another thing I like to do is I like to add some vertical zoom. So I'm going to go ahead and bump it up to 3. And let's go ahead and pull some cursors out. We're going to put that right about in 720. And I've already put 4 rulers out. And let's roll this thing up so we can look down here. The PV350 is a great transducer. It's a little noisy. So what I'm going to do is I'm just going to filter this a little bit. Alright, just at first glance, I noticed that the exhaust pocket is quite a bit lower than the intake pull. That usually indicates a leak in the cylinder. But if you have a leak, you usually have a leaning tower. Well, this tower looks pretty symmetrical. So we don't really have a leak. Engine vacuum is extremely bad. Negative 5.8, basically double that. So I've only got about 11, under 12 inches of mercury vacuum. That is not good for my area. My area should be, 18, depending on valve overlap and engine design. So I don't like the difference here. We're looking at 2.1 psi difference, and I damn sure don't like the engine vacuum being that low. Well, it goes to show low vacuum equals high compression. So this engine's getting added volume to the intake, which is giving me more compression. That kind of fits into my lean code. So now I'm thinking, all right, maybe we ought to start looking into this lean code, get it figured out so we can get our compression wave and our waveform kind of back in order where it should be. Also, low timing or bad ignition or cam timing can cause low vacuum. So kind of run into my first fork in the road. So you remember my theory. I says if this chain has jumped, it had to have jumped off the crankshaft because our cams are in line. So if it jumps off the crankshaft, then that means our exhaust and our intakes are going to be off. So I have no electronic monitor on my exhaust, but I have a pressure transducer in the cylinder. So let's look at that. So if I'm going to bring this over, first off, the cam timing looks good. I like to see the cam timing on these motors from the middle here and over this way. So I like the way that's falling. So my first indication is my exhaust cam is looking pretty good as far as timing. Same with the intake. About 20 degrees after top dead center, I like to see the middle or the upper side of the intake ramp. Okay, so I've got a correlation that's telling me it's off. I've got a scan tool that's telling me off, that the cam timing's off, but I've got a pressure transducer that's kind of telling me it's not. Exhaust valve opening, right in here where it makes a change, is fine to me. It's 130 to 150 is what I like. After top dead center, 143. The exhaust valve closes on this motor at 10 degrees after top dead center. So there again, 373, we're starting to pull this cylinder into vacuum. Intake valve shuts on this motor around between 600 and 610. I can't remember exactly, but that's kind of standard for our engines. So we can start looking right in here. I got about 606. It's starting to build pressure. So let's recap. I've got low engine vacuum, which could indicate cam timing. I've got high compression, which is a direct product from low engine vacuum. I've got cam sensors that are perfectly aligned with a crank that I feel like could be off. Now I've got a in-cylinder pressure wave that is telling me that my mechanical timing of this engine is perfect, or there's nothing wrong with it. So now I've got a bunch of pieces to a puzzle that I'm trying to fit together. So bear with me as I work my way through some more videos. This was right about quitting time, so I told Jason I've got about an hour, 15-minute commute. I said, man, I'm going to digest some of this information driving home. We'll come back in the morning and we'll attack this thing some more. I've got a lot to think about. This thing isn't fitting together. I'm 5, 6, 7 miles from the shop. I'm sitting at a stoplight. I get a text message. Jason says, "Hey man, I found a massive vacuum leak. I think it's going to change things." I'm thinking, man, that is great. So now, my high compression and my low vacuum, I could be solving this from what he has found. So check out these next little videos, and you'll see what I did, and then I'm going to show you some more compression waveforms.
I don't know if you guys can hear that, but we got that fixed first, and then we still have intake timing problems. So we're going to dissect those with this. Alright, so I have no command, but my timing is up, and the alphas are way lean. And as I was trying to show you these bolts, what I'm going to do is I'm just going to put this bolt in here. Somebody punched a hole through that with too long of a bolt, so we're going to get this fixed. Tighten this up. Look at that. Now you can already see the alphas are trying to correct, but this is still a problem. So we're going to have to dive into that.
So you saw in the little video where the major vacuum leak is, and as I was taking my finger and putting over the hole and off the hole, I had a WPS in number 2. Now this is the WPS. We were using Jason's Fluke 350. I went to the WPS. It was something I grabbed. This is actually the next day, the next morning, and we got back on this thing. So it's really neat. You can really see here the relationship between compression and vacuum. So over here we had the vacuum leak, and we're at 112 psi, which is too high. So we're getting more volume in the cylinder, so therefore we're compressing more, giving us higher compression. More volume equals less vacuum. Then when I covered the hole up, stopped the vacuum leak, through here you can see we were down to about 80, which is good. And of course our vacuum comes back, so that's always neat. So after he found the vacuum leak, I did that little playing around, and now I'm curious as to did that change anything as far as my valve timing. So we're going to look right in here where it's kind of fixed. You saw in the second video, the alphas were still high. It eventually stabilized. It took it a minute to relearn, but the alpha readings, or the short-term fuel trim, is what I'm talking about. Air fuel alpha is a term that Nissan uses. It finally got back to normal, but we still have our 20-degree cam issue. The engine's still running a little rough, and I'll show you why. But let's go ahead and set this up. There again, I'm going to zoom it up 3 times. Now we're in a low compression area, or a normal compression area, at about 81. We'll go ahead and drag these out just like we did when we had the PV350 in the cylinder. We'll bring this up. And see, I haven't filtered this, or at least I don't think I have. No, I haven't filtered this. So you can see the WPS is a little bit cleaner waveform. And I've heard, I don't know this for a fact, I've heard they've changed the PV350. So I know this is a very old unit that he has, and it's still really accurate. So if you do own one, definitely do some testing and make sure the accuracy is really good. So let's look down here. First thing I noticed is our engine vacuum. It's back. We're over 18 inches, which is great. That's why I like to see it in my area. And we noticed the difference in the pocket here is about 1 pound, 1 psi. I think before it was over 2. So let's look at our cam timing again. I see the exhaust is still in about the same spot. And maybe I wasn't clear about it, but I'll go over it again. The 180 or bottom dead center, I like to see it on our engines, or maybe any engine. I hate saying any engine because I don't look at a lot of engines. I look at our engines. I like to see it where it's at, but no more farther left than about the middle. You know, if it starts getting too far this way over here, if this 180 was over here, then things are happening too soon. If this were 180 in here, then things are happening too late. But 180 is right in there, which is fine. Our valve opening did not change. Our exhaust valve opening still perfect. Our exhaust valve closing is still right about 370. That's spec for this engine if you look at the cam card. And if we work our way across to intake valve closing, basically when it starts building pressure, I mean, you could split hairs, and anywhere in here is fine to me. So we've got the intake leak fixed. We've basically cured the lean codes. The multi-cylinder did not come back, but this car is still immediately tripping the two valve timing codes. They're both the same, and I was theorizing that if a chain did jump, it had to have jumped off the crank. This compression wave and the first compression wave is telling me that mechanically my engine is in time. So what gives? Let's go back to think. This thing had a CVT put in it. What's a CVT bolt to? It bolts to a flex plate. The flex plate is indexed. The crank sensor reads off of that. So that's when we go snooping around the flex plate area. Jason had taken the little access hole off, and I'm going to show you another video of me rotating the engine, and then you're going to see some steel shots where I kind of zoomed in with my camera to show you exactly what was wrong with the flex plate. The flex plate was broken. The engine mechanically was in time, but the flex plate had twisted and got out of time. I have seen these things break before, but the customer, I'm thinking, is trying to go back on the shop maybe that put the trans in and said they broke it. I don't know how that's going to work out for them, but I've documented the problem. And while the car was running kind of bad, I'm thinking due to some sort of strategy, the ignition timing. Let's go in here where I fixed the vacuum leak. This is ignition control for the number 2 cylinder that I'm actually in the cylinder on, and the falling edge is where it fires. So, you know, if that's top dead center, you can see it's firing pretty retarded on the ignition timing. I'm thinking that's some sort of an ECU strategy to protect something because it thinks the cams are out. Let's see here. And let's just see how late it is. Let's put these guys back out. So this engine should be firing the spark plug anywhere between 10 to 15 degrees before top dead center, and it's firing at about 9 degrees after top dead center, and it kind of gives it a sluggish revving. You seen where we put the bolt in the intake, the engine cover would have been there, and somebody put too long of a bolt in the engine cover and actually punctured the intake. We just stuck another little bolt in there. It seemed to have sealed fine. We did quote the customer a new intake. Obviously, I told them I'd just leave the damn bolt in there, but that's up to them too. They may be trying to seek some sort of liability for that. I don't know. Don't want to get involved with that. And you can see right here where I tell people all the time that port fuel injectors spray on the exhaust stroke, and it seems to be a hard concept to grasp, but there you go. there's bottom dead center. This from 180 to 360 is the exhaust stroke, where you can see right there. That's where the port fuel injector sprayed. It sprayed on the back of the intake valves. So now that fuel is kind of vaporizing, so when the intake opens somewhere in here, it pulls that vaporized fuel in, and then everything goes bang somewhere. Well, it's supposed to be over here, but over there. So I'm going to show you one more video. I'm rotating the motor around. You're going to see a couple of pictures, and then that's a wrap on this case study. I'm glad you guys stuck through it if you did, and looking forward to the next video. You guys have a good one. Thanks for watching, liking, and subscribing. Alright, before you get to the videos, I meant to show you this. These are the cam and crank correlations. Okay, so these top three are our bad car, or our car with the broken flex plate. And then about a day later or so, Jason ended up getting a 2012 Murano, and he did a quick cam and crank correlation of it. So now I have one to compare. Okay, so up here's bad. See the falling edge where it's in this gap? And I said I thought it was a little early. So you can kind of see where it's falling right in here. And when the cams are together, you know, it's kind of in the middle of this gap. Now down here's the known good. And see where the falling edge is here? It's more to the right. It's more towards this first tooth. And then when they're together, there's a little bit of discrepancy between these two. Might be a little slack in that chain, but pretty much the falling edge is right near the tooth where the car in question was over here. So one of these toggles is worth about 10 degrees of rotation, and this blank spot's worth about 20. So if you just kind of eyeball it, you know, from right here bad to right here good, I could see where the scan tool was pretty close to showing us 20. But I just wanted to throw that in there. Totally forgot to go over it, but now you have it. And if you want to take a screenshot, ignore the top one. That's bad. Take a screenshot of the bottom one, and that could be your known good for a 3.5 2012 Murano. As always, have a good one, and thanks for tuning in, and check out these little videos.
Alright, just to give you an idea of what I'm doing, I'm using a ratchet and I'm just cranking the motor by hand, and you can tell the trans has been put in this car. You can see kind of how clean this is and how not so clean the engine. So someone's put a transmission in this car. Not exactly sure what happened, and the GoPro is probably not going to do this any justice, but I did take some still shots with my camera. But the flex plate is cracked, and I think it's done spun on itself, giving us some incorrect timing. Because by the time you see this part of the video, you've already seen where I looked at cam and crank and had the WPS in the cylinder. But I'm not sure if they're going to fix this or not. But the flywheel is definitely shifted. I actually took a screwdriver and I tried to pop it back just to see, but we're going to find out because I'm going to start it right there. I don't think you guys are going to be able to see this with a GoPro, but straight up there, the flywheel is cracked and there's metal behind it, and I think it's actually shifted. So we'll see what this turns out like, and I'll put some steel photographs in there too. Thanks for watching.
So yeah, I kind of zoomed in with the camera. First you see all these metal flakes. Something had been rubbing pretty bad in there. But you can see the plate's broken right there. Pretty ugly. Borescope was a little clearer. I'm not sure what that is. Let's see, what other picture do I have? So rotate it around a little more and you can see some more carnage. Broken right in there. Broken right in there. So I'm not sure what's all wedged in there, but all this metal here, there was a lot of metal in that thing. So I don't know if a bolt got left in there and it cracked. I didn't see anything in there, but Lord knows what's going on with that. And then I rotated it a little farther and you can kind of see the crack right there, and then there's more stuff jammed all in behind it. So not sure what was going on, but the flex plate, it definitely moved. Hopefully the customer gets this thing fixed. I wish we could have fixed it, but I can kind of see their frustrations. But anyways, thank you guys for tuning in.